Okay, so what we have, we're working on equations of parallel and perpendicular lines. And we're just basically going to do a little, this is really, something from algebra, but understanding clearly about the what's often called the parallel slope criteria for parallel lines or the slope criteria for perpendicular lines. Understanding the relationships of slopes of pairs of lines that are either parallel or perpendicular. In this case, we have a problem and it says we want a line that's parallel to this line. Now this line has a slope. We use y equals mx plus b. So it has a slope of 2x minus 3. The slope is 2. The coefficient of x, that is our slope, so 2. Which tells us that, from any point here that we start at, it would rise to and over 1. Its slope triangle, if drawn out, would go to the right 1. That's our run. It would run 1 and rise 2. So I would draw it like this. If I were writing on the board, I'd write a 2 in here over 1 down there. In fact, let's just write that out. We say y equals 2x minus 3. And this, what this indicates, is that my line moves like this. In a run of 1, it rises 2. Okay, and this would not really drawn to scale. It's going to be steeper, right? Because it would go over 1, but it would rise, on 2 units. 2 over 1. So that's our slope triangle right there. We say for a line to be parallel, right, it has to move in exactly the same way. I like that letter M for slope. It comes from, the French word for mountain, montagne or something like that. I don't know how they pronounce it. But basically, like the slope of a mountain. I like thinking of the English interpretation of M. I call it move because it tells us how the line moves, right? In this case, this moves positive 2. It goes, for every unit over, it goes up 2. Every unit over, it goes up 2. And if I go over 1 and up 2, I'll get right back to my line again, over 1 and up 2. So a parallel line to it has to move exactly the same way. It has to go over 1 and up 2. If it doesn't go over 1 and up 2, it's going to eventually either run in, like if it goes a little higher, it'll run in up here. If it doesn't go quite as much, it'll be a line that runs into it down here somewhere. Right? If it's a flatter slope, it'll run into it. So it has to have identical slope. So I know already that my slope is going to be 2. Okay? And then the last thing here is I've got to find out the intercept. Okay? So my intercept is the point at which it crosses the y-axis. Well, I can just say from this point I would go down 2 over 1, right? Because that's my slope. And I go down 2 over 1, and it would be at negative 7. I like having the image there. We don't have to do a lot of the algebra to figure it out. Okay? You can do it graphically, and they're very simple to solve. Now, if you want to do them algebraically because you're some kind of a, you're an algebra nut or you have great visions for other things you're going to do in life and you want to know how to do that, you would say like this. You'd say y equals 2x plus b, and we want to solve for b. So we're going to substitute in a point that we know. In this case, we were given the point 2, negative 3 as a point on this line. So we would put, under x, we would put 2, right? We would substitute 2 and negative 3 there. Okay, so plus b. And we could just do that math, right? 2 times 2 is 4 plus b equals negative 3. We can subtract 4, and these are going to cancel, and we get b equals negative 7. Negative 3 take away 4 is negative 7. So you can do those if you want by hand, but I like seeing them graphically. And so you can use Khan Academy, you can use GeoGebra to solve this too if you want. We're not going to do that because it's simple enough to see it. It's already plotted out here for us. So here we go. Let's see if we can get a couple more of them. This one also says it's parallel. I like this one because notice there's no slope listed. Sometimes I'll see kids and they'll say, oh, 0, there's no number there. It must be 0. Well, if this was 0, 0 times x would be 0, and the x would be gone. So this is one of those cases where we have a number in front of 1 that doesn't commonly get written. And the number in front of x that doesn't commonly get written is 1. It's like saying, I'm going to eat an apple. We don't usually say, I'm going to eat 1 apple, right? We just, going to eat an apple, but we don't say 1 apple. So the same thing's going on here. We have an x here, but doesn't mean, it's an implied 1. We could say I have 1 x here, but it's not written as 1. It's just an x, okay? So now we want to be parallel here. We need to have a slope, and it's going to go like this. It's going to go up right here. So the slope has the same number there, 1. And then the intercept is going to, starting from here goes over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. And it's going to run into the y-axis right here at positive 8. So that's all you need to do. If you understand what a slope is, then you're going to be fine here with these problems here. Find the slope and y-intercept. The line is parallel. This one goes, now when it has a fraction, the slope means it goes over 2, up 1, right? We go over whatever the run is on the bottom, right? And then up whatever's in the numerator. So the denominator here tells us to go over 2, up 1, over 2, up 1, over 2, up 1. And we're still doing parallels here. So this one's going to go over 2, up 1, over 2, up 1, like that, right? And it goes down 2, back 1. So it's going to have the same slope of 1/2, and it's going to intercept the y-axis at 5. So I put 1/2 here and 5, and that's how these are done. I wonder if we're going to get a perpendicular one here. I think we're supposed to get some perpendiculars too. Here we go. We have, right there's our slope, and our slope is 1/3, which means that we go over 3, up 1, right? So we're going to go over 1, 2, 3, up 1. Over 1, 2, 3, up 1. Uh-oh. This one does not indicate where it crosses. It doesn't cross the x-axis at a very clean point, does it? Well, just remember, if it takes 3 to go up a full one, then it's going up 1/3 at a time. It goes up 1/3 here, then it goes up another third, so it's 2/3. Then it goes up the last third, and it's up to 0. So this is 0. This down here would be at -1/3, and down here would be at -2/3, right? And down here we're down at -1. It's climbing at 1/3 of a unit for every one run here. So we could say that that is going to be a -2/3. Okay. This is a good one. We may as well. Let's just look at solving that with the calculator. We could do that too, right? So let's try that out. And I'll try to zoom this in for us. You can just watch. We're going to do a solve command. And it's very good, especially if you struggle at all, and I have a lot of kids that struggle with algebra. So let's go ahead and use the calculator, let it help us with the calculation. So here we go. We're going to go menu, algebra, solve. We're going to put that equation in, but we're going to substitute in the values. So we know we have y is -2. Then we have is equal to 1/3 times x is -4. So here we go. So we're going to go -2. Was that right? Y was -2, yeah. So we say is equal to, control divide gives me a fraction. I go 1/3 times 1/3 times -4, right, plus b. And I want to solve for b, so I put a comma. You see that? Okay, comma b. So this is my expression. I've substituted y value here, x value here, the slope goes here, and I want to know what b is. So please solve that for me, calculator. And it tells me that b is -2/3. So we solved it with the CAS, and we can also solve it graphically just by intuiting it from looking over this way. Go over 3, up 1, and we're going to go over 1, and we're only going to get up 1/3 of the way, and that's to -2/3. All right, parallel yet again. Here we go. We're getting all parallel lines. This one goes down 1/2. So down 1/2, down 1/2, down 1/2. So we're going to go right through here, and it's going to go halfway down and then the full way down over these. As it makes this run of 2 right here goes down 1/2. It doesn't go in this direction. It goes as a straight line, right? So it's going down 1/2 and over 1, and then going down 1/2 more and over 1 more. So as it crosses here, it's gone down 1/2. So the intercept is going to be -1/2. And guess what? The slope is also -1/2. I think we need to see some perpendicular ones. Let's see if we can do this one. Let's try this again. We need perpendiculars. Ah, yes. Okay, good. We got a perpendicular line. So let's talk about a perpendicular line. Let's just think about this real quick. The perpendicular line, and while I'm talking here, I am going to get my I think I am going to bring up GeoGebra here real quick. So I'm just going to, I'll go here and we will click on GeoGebra and let that start coming up. But in the meantime, let's talk about what it means to be perpendicular. One is going to move in one direction. The other has a different slope. It's not the same slope. And I've heard kids say, well, it's an opposite slope, right? If lines meet in a perpendicular fashion, they say, oh, that's an opposite. And we know this is going to be true to some extent. And basically, it means that if one line is moving in a negative fashion, the other one's going to have to be positive. So if the slope here, let's call this line A. So if slope A and line B here, slope A and slope B, if they're perpendicular, if we multiply them together, they're going to equal negative. Oops, they're going to be a negative because one's going to be positive, the other's going to be negative. So we're definitely going to get a negative when we multiply them together for the products of those, okay? Now it turns out, I've blown it right here, but basically the big secret is that as you multiply slopes of perpendicular lines, you get -1 is the product. And we'll just make a couple of lines. Let's make this line, and then let's make a perpendicular line. And now let's measure our slopes. So we'll really quickly measure the slopes of these lines. And this is not going to work out perfectly because there's some rounding in there. But if I use my calculator and I say, what is -1.2 times 0.83? And you can see I'm doing that here. Okay. So my answer should be really close to -1. And you can see it's very close. It's not because there's some rounding going on here. Okay, but basically it should be -1. And if we showed the real number here with, whatever it was, it would be equal to -1. Now, if I were to adjust this line in any way, let's try adjusting it. Sorry, let me adjust this slope here. You'll see that the other has to adjust, and we get another number here. So here we go. -2.33 times 0.43. And if you do that, you'll get 1.0019, -1.0019, which is basically -1. All right, so back to our work here. We have a slope of -1/2. So our slope is going to be positive. And in actuality, what we want to do is we want to go the reciprocal of this. So instead of 1/2, it'll be 2/1, and it'll be positive 2/1. So this one's going to go up 2/1, up 2/1. So it's going to cross here at 6. So we have a slope of 2 and an intercept at 6. Okay, that's how those are done. Rise 2/1, rise 2/1. And I know that because it's a positive slope, because this one is negative, right? The -1/2 is a negative slope. And my perpendicular slope line is going to have the opposite sign. It'll be positive, and it'll have the reciprocal here. Let's go to the next one. Aha. So now it says, what do the following two equations represent? So, of course, we have a couple of ways. And now, of course, when I'm almost out of time, we'll have to enter these quick. Let's put it into the calculator, or the GeoGebra, we can put it in there. So I can put it in and say, what is 3x minus 4y equals -1. And I'll get that line, and then I'll put in the next line, that is 5x plus 2y equals -5. I hit enter, and now, I've got, what was the first line here? This was the first one. That's the second one. They sure don't look to be parallel, and they don't look to be perpendicular either. Of course, I can measure, I can measure the angles, but I'm not going to do that right now. I should do that real quick, but I'm not going to because we're out of time. So that can be done. I can also use my CAS tool here. Go to CAS, and I can solve each one of these. So I can do a solve. Let's see, not evaluate. Where's my solve for x? So I can do a solve for y. Solve. Well, I don't know how to use that. I'd do my other calculator, get it done. Anyway, my answer is none of the above.